Welcome back to Intellify. I'm Rasika Ramakrishna and let's continue the chapter on applications of trigonometry. Exercise 9.1, question number 16. The angles of elevation of the top of a tower from 2 points at a distance of 4 meters and 9 meters from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meters. Alright, so now this is a pretty straightforward diagram, but the question as such is not straightforward. We have not seen something like this before in this exercise. This is the first time we are given absolutely minimal information and we are asked to find, in this case, prove something. Alright, so the diagram is straightforward in the sense that this is something we've seen a lot of times. So we have AB to be your tower, and from a point C, which is 4 meters away from the base of the tower, we have the angle of elevation to be something. And from a point D, which is 9 meters away from the base of the tower, we have the angle of elevation to be something else. We are not given the explicit angles of elevation. Instead, we are told that they are complementary. So what does complementary mean? They sum up to 90. So therefore, let us assume that ACD is equal to x. Then we have ADC to be equal to 90 minus x. Alright, so now before we go ahead and try to prove that the length of AB is nothing but 6 meters, let us notice that AB is common to both triangle ABC and triangle ABD. We will somehow make use of this fact to prove that AB is equal to 6 meters. So let's see how we go about it. So let's consider right triangle ABC. So tan x is going to be equal to AB by BC, right? Opposite by adjacent. So tan x is going to be equal to AB by 4, which implies that AB is equal to 4 tan x. And we call this equation 1. So now let's look at right triangle ABD. Here we have tan of 90 minus x to be equal to AB by BD, right? Again, opposite by adjacent. But here what happens is, we know that tan of 90 minus x is nothing but cot x. Therefore, we have cot x to be equal to AB by 9, or AB equal to 9 times cot x. So this we call equation 2. So notice that we have obtained two expressions for AB, one involving tan x and one involving cot x. And what else do we know about tan and cot? They are always, the product is always 1, right? Because tan x is equal to cot of 90 minus x. Because of that, tan x times cot x is always going to be 1. So this is a basic trigonometric identity, and this is exactly what we're going to be using to find AB. So we have AB squared to be equal to 9 times cot x in times 4 times tan x. So since tan x into cot x is 1, we have AB squared equal to 36, which implies that AB has to be plus or minus 6. Now, since height cannot be negative, we have the height of the tower to be 6 meters. Hence, we've proven this question.